Okay, for class 10 children, we are recording one theorem. We have already done two theorems with you. The first theorem which I did was double angle theorem. That angle subtended by an arc at the center of a circle is double the angle which it subtends at the remaining part of the circumference, and we called it double angle theorem. We gave one video in which we actually change the angle at the center, accordingly the angle at the circumference changed, and you saw that. Then we did next video we did was about segment, and we also did that angles in the same segment of a circle are equal, and we explained it quite thoroughly, the theorem. We made a figure in which we showed what a we explained you thoroughly what a segment is, and accordingly we did the theorem that angle in the same segment of a circle are equal. Segment is the area included between a chord and the circumference, a part of the circumference. Angle, the area included between the chord and the part of the circumference. If it is major arc, then major sector is formed. If minor arc is there, then minor sector is formed. Now we are doing a very interesting theorem, which is also, all these theorems are related to each other. The statement is the angle in a semicircle is right angle. Right angle. Angle in a semicircle is a right angle. So whenever a semicircle will be there, the angle formed in the semicircle will be right angle. Let us make the figure and show it to you. Like this is a circle. Let me draw the diameter of this. So this is the diameter. Now this diameter divides the circle into equal halves, and each part is called a semicircle. Exactly, it is not looking like the diameter, but I am assuming it to be diameter because I am taking O as the center on top of it. Now, if I name it the diameter to be AB and name it as P and name it as Q, then the diameter divides the circle into two equal halves, and actually it is making two segments. One is the segment AOBPA, AOBPA. Another segment is AOBQA. Both segments are equal in area. Both segments are equal in area. Now let us see this arc. Let me take the arc APB. This is actually circumference of the semicircle. This arc APB, let me take another color. Now this arc APB is subtending an angle AOB at the center. This arc APB subtends an angle AOB at the center, and at the remaining part, suppose let me take this. Sorry. Okay, let me draw. AOB is the radius. is diameter, and let me draw this line, and let me draw another line. Okay, so you can see in this circle the arc APB makes an angle AOB at the center, and this angle is how much? This is 180 degree. This is 180 degree. This angle is 180 degree. The same arc, according to the double angle theorem, will make angle AQB to be 90 degree. This angle AQB will become 90 degree. So angle in a semicircle is always a right angle. This is actually a corollary of double angle theorem. What is given is, let's write down, given is a circle with center O, a circle with center O, center O. A circle with center should be TER. A circle with center O. Just a moment. Just hold on. Let me. The TRE is okay. Center O. A circle with center O. A circle with center O. AOB is diameter. Is diameter dividing the circle into two equal halves. Two equal halves. This is given to you. This is given to you. Now what is required to prove? Required to prove is that angle AQB is 90 degree. Angle AQB is 90 degree. We have to prove angle AQB is 90 degree. What is the proof? The proof is the angle AOB is 180 degree. It is a straight line. 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 Though I have done this when I was depicting the angles subtended by the arc at the center, then this particular condition was also brought in that you will be seeing in my earlier videos. But I'm going to prove it now. AOB is 180 degree. This is the angle. This is the angle subtended by arc APB at center. At center. This is the angle subtended by the arc APB at the center. The same arc, the same arc, the same arc APB subtends angle AQB at the remaining part at the remaining part of the circumference, at the remaining part of the circumference, at the remaining part of the circumference, at the remaining part of the circumference. This angle, the same arc subtends angle AQB at the remaining part of the circumference. So angle AOB will be double of angle AQB. This is 180 degrees. Sorry, this is 100 and this is 100 and AOB is 180 degree. Is double of angle AQB. So angle AQB will be 180 upon 2, that is 90 degree. So angle in a semicircle is always a right angle, and this property we have used earlier. This property has been used by us earlier in construction of a right angle triangle. In construction of right angle triangle, I'll just explain how to you. I'll just explain it to you now after this, that how we use this property for constructing a right angle triangle. So angle in a semicircle is always a right angle. Always a right angle. Angle in a semicircle is always a right angle. Angle in a semicircle is always a right angle. Right angle means 90 degree. Please understand clearly that because APBA is also a semicircle, and suppose I would have taken some point along APB, that angle will also form an angle of 90 degree. Also, the position of Q is not unique. The position of Q is not unique. It could be anywhere between A and B on that side. Like, I'll draw another figure for you. For example, this is a circle, and if I draw a diameter, suppose this is diameter, and let me take, sorry, why it is troubling me, this color. Okay, let me draw a straight line, for example. What's happening now? That is what is happening. Okay, now remove this completely. Remove this. What's happening? Okay, let's draw the circle again and draw the diameter. Okay, then draw. Okay, doesn't matter. Okay, this is come one. This A O B is diameter. AOB is diameter. Now this Q is here. This Q is here. So let us take another color. I can write Q1 here. Suppose I write Q1 here and draw a line here and draw a line here. Q1. So AQ1B. Suppose I take another color. I take black color and okay, black color, okay, and then remove this, okay, and then I have drawn Q2, and let me take one more figure. Sorry, let me take green also. Let me take green also, and let me make okay Q1, Q2, Q3, Q3. It is Q3. It is Q3. Okay. Now there are four angles formed. There can be many more angles formed. I have angle AQ3B. I have angle AQ2B. I have angle AQB. I have angle AQ1B. All these angles are 90 degree. Angle in a semicircle is right angle. Angle in a semicircle is right angle. Angle in a semicircle is right angle. But it is not necessary that I should have taken the upper portion of the circle, semicircle. I could take the lower portion also. I'll show you here. This is the circle. I have AOB as the diameter, and let me make P1, then P2. I can take P3 also, and I can take P4 also. I'm just not making it too complicated so that it should be clear to you what is there. I'm saying angle AP1B is equal to angle AP4B, angle AP2B, angle AP3B is equal to 90 degree. Please understand all three theorems which we have read are applied in this. The two theorems which we have read before this are applied in this. What number for one theorem was the angle subtended by an arc. Let me mark this point as Q. So this arc AQB, the arc AQB is making an angle AOB at the center, which is 180 degree. This arc AQB makes an angle 180 degree at the center. Same arc AQB is making angle AP1B, AP4B, AP2B, AP3B at the remaining part of the circumference. So all those angles will be half the angle of what it is subtending at the center. At the center, it is subtending an angle of 180 degree. So at the circumference, it will subtend an angle of what? 90 degree. It will subtend the angle at remaining part of the circle at 90 degree. Now please just see the another theorem which we have studied today. Angle in the same segment of a circle are equal. Now please understand this AOB P3, P2, P4, P1, A is a segment. This is a segment. What is a segment? Area included between an arc and the part of the circumference. AB, the diameter is also segment. It is the biggest segment of the circle. It is the biggest chord of the circle. AB is the biggest chord of the circle. And AP1, P4, P2, P3, B is circumference or part of the circumference. So this is the same segment. Angles in the same segment are going to be equal. AP1B is equal to AP4B is equal to AP2B is equal to AP3B is from the same theorem. Angle in the same segment of a circle are equal. That is why they are all are going to be equal to 90 degree. Similarly, if you see in this figure, which I have drawn in more colors, AOB AOB is the diameter. AOB is a chord, biggest chord of the circle. And this above portion AQ3, Q2, Q, Q1B, A is segment. Angles in the same segment of a circle are equal. That is why we have written, if you see, AQ3B is equal to AQ2B is equal to AQB is equal to AQ1B. So angles in the same segment of a circle are equal. That theorem is applied here. And also we have applied that angle subtended by an arc at the center is double the angle which it subtended at the remaining part of the circumference. So we have made the application of both those theorems into this theorem to get this theorem. Okay, now I had told you that I am going to tell you also that how this particular theorem or property, which is very important property actually, this property that angle in a semicircle is always a right angle. How do we use it in construction of right angle triangle? Generally, one of the questions which you must have got most of the time in class 8th on to 9th also, that to construct a right angle triangle, I'll write down, to construct a right angle triangle, a right angle triangle with hypotenuse 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 equal to 5 centimeter and one of the remaining side one of the remaining sides as 4 centimeter as 4 centimeter. To construct a right angle triangle, with a hypotenuse is equal to 5 centimeter and one of the remaining sides is 4 centimeter. So in this kind of a question, what we used to do was, we will draw a hypotenuse. This is hypotenuse which is 5 centimeter. It is not to the scale. It is not to the scale. AB is much bigger than 5 centimeter. AB is bigger than 5 centimeter, but I am drawing a little bigger figure to make it clear to you. AB is 5 centimeter. So first of all, we draw the hypotenuse in this kind of a question. Then we bisect AB. How do we bisect AB? Take A as the center. That means put the needle of compass at A. Open up your compass more than half of AB and draw an arc this side and draw an arc this side. Similarly, taking B as center, with B as center, that means put the needle of the compass at B and draw the arc with the same radius. Radius is more than half of AB. So somewhere here, suppose C comes out to be the center. I am not joining this to this. This will not be correct. But the method is this. And for this, you don't draw it with the hand, which like I have drawn. You have to use the compass. You have to use the compass to draw these arcs. An arc should be drawn on both sides, or above the line and below the line, because then only we can join and we get the point C. Now with C as center, and CA as radius, we will draw a semicircle. This is not a semicircle actually. This has come some other shape. It's not semicircle because it has taken the shape what I have given. Uh, so I'm not going to try it, make it very nice. Whatever it comes out to be, I'm going to draw that. This is the semicircle. This you get as the semicircle. Now, what are we going to do? Whatever is the second side, for example, one of the remaining side is 4 centimeter. Either take B as center or take A as center. Whatever the name of the side is given. If name of the side is not given, then it does not matter. You can take A as center also and B also as center. Suppose I am taking A as center. Open up your compass 4 centimeter and cut an arc. Open up your compass 4 centimeter and cut an arc. I have cut arc at the wrong place. Why I have cut the wrong place, arc at the wrong place, I'll tell you just now. Because this AC will be how much? 2.5. So it has to be greater than that. It has to be greater than that. So it will be somewhere here. Suppose I don't have to write C. C is all no. Let me make it O. Let me make it O. C is there. Now what you do is you join A to C and you join C to B. You join C to B. Automatically you will get this angle as 90 degree. You will get that angle as 90 degree. So angle in the semicircle, this construction is done on the basis of that angle in a semicircle is a right angle. Angle in a semicircle is right angle. What have I done is I have drawn hypotenuse as the base. Hypotenuse as the base because opposite to hypotenuse will be the right angle. So I have drawn the hypotenuse of 5 centimeter, bisected hypotenuse with the help of ruler and compass. I got the midpoint of AB as O. With taking O as center, OA as radius, I have drawn a semicircle. I have drawn a semicircle. Then with taking A as center, I have opened up the compass to a radius of 4 centimeter, which is another side, 4 centimeter, and cut an arc. Cut an arc. So AC is 4 centimeter. So by your common knowledge, this will come out to be 3 centimeter. This will come out to be 3 because this is 5, this is 4. So automatically that side will come out to be 3 and this angle will be always 90 degree. So that is how we use this property that angle in a semicircle is always a right angle. At this point, I'm stopping this theorem. Thank you.